Hi viewer, this is Sri Ramulu. So today's topic is half wave rectifier. So see here, an electronic device, used for converting AC voltage or current into DC voltage or current is called rectifier. Okay, so this is a electronic device which convert AC voltage or current into DC voltage or current is called rectifier. Next, for this purpose, a unidirectional conduction device such as PN junction diode is used. So to convert the AC into DC, then what we have to use? We have to use a PN junction diode. A half wave rectifier is one which convert AC voltage into pulsating voltage using only one half cycle of the applied AC voltage. Here what half wave rectifier is, it convert AC into DC, AC into not complete DC. It is a pulsating, means it also contains a small certain amount of AC, so which contains a certain amount of AC, that is called pulsating. So pulses means like this, okay, like this or like this. Okay, next, the basic half wave diode rectifier circuit along with its input and output waveform is shown in figure A. So it is a diagram, okay, it is a basic diagram. See, so this is a basic diagram and it contains, and see, this is a transformer, and transformer which contain this side number of coils. Those coils are called primary coils and this side are called secondary coils. So primary coils are denoted by NP and secondary coils are denoted by NS, and it is always primary coil is greater than the secondary coil, and it is a diode, and it is a load resistance where we get output voltage, that is across the resistor, at which resistor we get output voltage or output current or voltage or power, that is called a resistor. Okay, so the load resistor. So at load resistors only we get output. It is a basic diagram. And next, the AC voltage to be rectified is applied to a single diode connected in series with the load resistance R. So here what I am doing, I am applying the AC voltage to the rectifier. Okay, so that rectifier contains a single diode only, and to this diode there is a resistor, load resistor, that is connected in series. So just now I have shown you diagram. Okay, see once again diagram. So it is a diode, right? Okay, sorry for this disturbance. And it is a diode. To this diode, this resistor is connected in series. It is not in parallel, it is in series. Next, working. See here. For the positive half cycle of input AC voltage, the diode D is forward biased and hence it conducts. So you must know the certain things about the diode. Suppose if it is a diode, okay, so diode generally we denote in this manner. That means this side is a p-type material and this side is n-type material. So when the positive half cycle is given this side, it is positive and this is also positive, it becomes forward bias. If we give the negative cycle, then it is a positive one, p-type means positive one, it is negative one, then diode becomes reverse biased. Okay, so when you give the positive cycle to the positive p-type material, then only it is forward bias, otherwise it is reverse bias. In forward bias it allows a current, in reverse bias it doesn't allow the current. So in forward bias the diode act as a on state, and in reverse bias it act as off state. So that means the diode can be act as a on off switch, like a on off switch. Okay friends, The now a current flows in the circuit, and there is a voltage drop across the RL. So just now I have shown you diagram. See this diagram. In this diagram, what happens here? What is saying? Now the current flows through current flows in the circuit, and there is a voltage drop across load resistance. So when current flows in this direction, then what happens here? The certain voltage will drop here. That voltage will be appear at the output, and that output we take outside. And next, this constitute output voltage as shown in figure. So this is output is shown in here like this. It is output and it is also output. If it is about the current voltage, it is a current diagram. So two diagrams are given. That is for the what you know. If it is input is a voltage signal, then you get this diagram. If it is a current, belongs to the current, then you get this one. So like this, two outputs are shown here. The first one is input one. It is input. Okay. So input is it is input and it is output and it is also output. If it is input is current, then diagram is this one. If input is voltage, then diagram is this one, second diagram. And now the waveform of diode current or load current. Diode current, either it is a diode current or load current, okay, is shown in figure C. So it is a figure C. It is about the current and it is about the voltage. Here in the side is given C. If it is voltage, then the output will be this one. If this diagram belongs to current, then output is this one. Why? Because here the current is given. Okay. Next, for the negative half cycle, the diode D is reverse biased and hence it does not conduct. In reverse bias, it acts as a off state. So that means it cannot allow any current. Now no current flows in the circuit. So ID is equals to 0, then VO is equals to 0. ID means diode current or load current, either diode current or load current. So when load current is 0 or diode current is 0, then no, you cannot get any output. So output voltage is 0. Next, it is obvious from the figure that output is not a steady DC but only pulsating DC wave. So what he is saying, it is obvious from the figure, means from the figure output is not a steady, it is not a constant DC, it is not a constant DC but only pulsating DC. So that means it is a pulsating. So you have just now you have seen like this diagram. So it contains only unidirectional, means not only AC, it contains certain amount of DC also it contains. So that is a pulsating DC it is. That means it has pulses. See once again diagrams. This is, see, output is waveform like a pulse type. When it is measured by DC meter, it shows some average positive value since only positive half cycle of the input wave is used, hence it is called half wave rectifier. Why its name has come, as half wave rectifier? Only positive half cycle it uses. That is why it is half wave rectifier. It contains one diode. And when if you measure this output pulsating DC with a certain DC meter, then it shows average value, not a exact value, it shows average value. Okay, let the diode be idealized with a reference with the resistance RF. RF is forward resistance, we call it is forward resistance in the forward direction, that is in the on state, and in reverse direction, that is in off state. Next, now current I in the diode or in the load resistance RL is given. See here the current. What the waveform we got? If it is input wave, let it is a belongs to the current. Then output is what? It is positive one, it is negative, positive, negative. In half wave rectifiers works with only positive half cycle. That means when this cycle is there, that cycle appear at output. Let it is output and it is input. Okay, at output only this one appears. It is also current. Okay, then during this negative half cycle it do not conduct, but next second half cycle it conducts. It shows the output like this, and next negative half cycle it do not conduct, and again next half cycle it conduct like this. So that means you may get like this pulse, it is one pulse, it is one pulse, like this. In the pulse form you can get. Okay, and see here it is a zero angle. Generally if it is a wave, anything, if it is a wave, and how much angle it contains, from here to here it is 180 degree, and here to here is 180. So total this wave contains 360 degree. In terms of degree 360, but in terms of radian we write it is 2 pi. In terms of degree it is 360, in terms of radian 2 pi, and if it is 180 degree, in terms of radian we denote with pi. Okay friends, so you must keep in mind pi. Alright, here the only the output is for positive half cycles only. So that means 0 to pi degrees only, positive half cycle. Okay, so remaining pi to 2 pi degree it doesn't work. So that for negative half cycle, for this half cycle diode is in reverse bias, means it do not conduct, but during this half cycle it conducts. That means 0 to pi only. So we are getting the current in 0 to pi. So it is 0 to pi only we get the current, and remaining pi to 2 pi. So pi to 2 pi. So during this half cycle we do not get anything. So that is why current is 0 here, like this. And here Im is the maximum, it is a maximum current, and a maximum current can be written as the maximum voltage by resistance, load resistance plus forward resistance. So that is why it is written like this. And next, DC output current or average current. See here I have written average word. Why? Because if you take any DC meter, it measures only average value only. So that is why the DC output current or average current here we are going to calculate by using equations or formula. And see here it is the equation. So this is the equation. And average in mathematics, in integral form, average can be taken as like this always. So keep in mind, if it is a current is, and if you take its average, then for in between cycle, here the full cycle only we have take for full cycle. So it is a current I is equals to integration 0 to 2 pi you have to write, and current I by d omega t by 0 to 2 pi d omega t. Okay, it is general formula, but basically in lower classes what you have learned, average means sum by number. Suppose there are the two quantities, one is x and other one is y. How many quantities? 2 are there. Then x plus y by 2 you may write. So in numerator you are writing, in denominator also you are writing. So that is why in integral form, in numerator also you are writing, and in denominator also you are writing. So this concept we are taking here. Next, okay, so average equation is this one, and now this is average is written like this. Okay, for 0 to 2 pi only, for full cycle I am taking. For full cycle it is half cycle, and remaining it is half cycle. It is a pi radian and it is also pi radian. So total 2 pi radian. Where to where? From 0 to 2 pi radians. Okay, so see here IDC, and here the values current just now I have explained above you, and see here above, this above is also taken below also this side, and see here during the 0 to pi certain value is there. Okay, and pi to 2 pi you don't have any values, so no current. So 0 to pi you have the value. Okay, and pi to 2 pi you don't have. In next step, see here, See here, same thing, this is also taken outside. So 0 to pi, 0 to pi you have the value that is Im sin omega t, and pi to 2 pi, pi to 2 pi, what is the answer? 0. So pi to 2 pi answer is current is 0, but 0 to pi current is this much, it is written here, and we know that. So see in the denominator, in denominator integration 0 to 2 pi d omega t is there here, and nothing means understand here 1. So 1 integration with respect to d omega t is omega t only, where to where? 0 to pi. If you 0 to 2 pi, okay, 0 to pi, if you substitute this limit, first substitute 2 pi and then minus, and substitute 0, 2 pi minus 0 becomes 2 pi only, so that is why here 2 pi is written. And next, here the values are substituted and this becomes 0, only we get 0 to pi only, so 0 to pi. Now common factor, these two are common, taken outside, sin as it is. Next, integration of sin omega t is cos omega t, where to where? 0 to pi, and take it minus outside, minus is taken outside, okay, minus is taken outside here, and now substitute first pi and then 0, minus after minus doing minus 0, okay, cos pi minus 1 and cos 0 is 1 only, here minus is because that is why it is minus, minus 1 minus 1 minus 2 only, okay. So this minus minus become plus, right, and 2 1 ja 2 1 ja, okay. So then we got IDC as Im by pi. So DC current is Im by maximum current by pi. Next, DC output voltage. DC output voltage according to Ohm's law, voltage is equals to current into resistance, okay. At output resistance is RL, and see here IDC value, IDC value how much you got? Im by pi, it is okay. Now come here, and in the place of Im, substitute Vm by Rf plus RL. So in the place of Im it is substituted by pi is there. So from the above figure, see here this figure, in this figure here IDC is equals to VDC is equals to Im by pi. Im value is how much? Im value it is this much. So in the place of Im substitute only by pi, by p, pi as it is only, and from this denominator take outside RL, take outside RL. If you take outside RL, it becomes like this, RL gets cancelled, and in practical RL is very much greater than the RF. Actually input resistance is very low. Then what happens? This factor can be neglected. Then finally we write VDC is equals to Vm by pi. Next, RMS, the RMS current. The value of RMS current is given by, so it is RMS current only, and RMS current means root mean square, root mean square. So root is given, okay. Mean means just now I told you integration by once again integration, okay, and square is there, I square. Why it is I square twice means between the two values 0 to pi half positive half cycle and pi to 2 pi negative half cycle, for positive half cycle and for negative half cycle, okay. And here for positive half cycle, so 0 we know 0 to pi is answer is this one, and pi to 2 pi answer is 0. So substitute 0 value, it becomes 0 and only get this one. And from this Im, here see here under root is there, here under root is there, but inside square is there. So Im sin omega t whole square means Im square is also there. So Im square is taken outside and 2 pi also, so it is written outside this side, and integration 0 to pi sin omega t whole square d omega t, and it becomes sine square. Sine square formula, sine square can be written as like this: sine square 1 minus cos 2 theta is equals to 2 sine square theta. But here only sine square is there, that is why I bring this to this side. So 1 minus cos 2 theta by 2 is equals to sine square. So here in the place of sine square, 1 minus cos 2 theta by 2. Next, and now to right outside, this is written this side, then it becomes 1 minus cos 2 omega t d omega t. Now integrate, apply integration inside. So if we apply integration inside, it becomes like this here and here, and its integration value we know that is omega t. Why? Because we are integrating with d omega, with omega t. Okay, and here cos omega t, 2 omega t, cos integration of cos is sine, but 2 is there, by 2 is we have to write. Okay, sine ax integration is cos ax by a. It is a formula, cos ax by a. And next, now limits where to where, from 0 to pi. Now apply the limit first, apply to this one and apply two values this one. First put the pi value and next minus 0, and here also first to put the pi value in the place of omega t and next 0 in the place of omega t, it becomes 0 only, right? Now its value is 0, sin 2 pi is always 0, okay, and it is also 0, so 0 0, it is also 0. So finally we got pi here, pi gets cancelled, okay, and here under root is there. For under root, a square gets cancelled, but 4 becomes 2. So IRMS we got Im by 4, and next to the RMS voltage, RMS current over RMS current is Im by 2. RMS voltage can be written as, according to Ohm's law, Vrms is equals to Irms into load, means voltage is equals to current into resistance. Okay, now Vrms is equals to, just now I got Irms as Im by 2, okay, but we know Im value is this one. Take this value and substitute here, so 2 is also written as it is into RL. Now take outside RL common. If you take RL common, RL gets cancelled, then you get this one. So if you apply this condition, then this term becomes 0, neglected, then Vm by 2. Next, efficiency. Efficiency means this device, how much AC is converted into DC. Okay, how much it is. Yes, it is saying that it is converted AC into DC, but how much it is DC into AC, how much it is converted DC into AC, or AC into DC. Okay, rectifier is which convert AC into DC. So the ratio of DC output power to AC input power, and it is denoted by neta. Okay, so ratio of output power to input power. Input power we have given AC, and we are getting output DC. Okay, so that is why output power DC by input power AC. So for this power, for DC power is power expression is power is equals to current square into resistance. So here current square into load resistance is taken. And next DC, IDC. For DC, if it is a DC power, then current is also take DC current. So for DC current, just now we got as Im by 2, isn't it? DC current is Im by 2, but it is square is there, so whole square is there, then it becomes Im square by pi square. Next, AC power, PAC is equals to power is equals to I square into resistance. So here two resistance we have to take for AC only, for only AC. Why? Because not only present AC at output and also present at input, so input resistance is RF. Okay, for DC only we have to take output resistance. Why? Because DC we get at output only, we do not get input. Okay, that is the reason why it is written RL plus RF, because AC not only present at input and also present at output. Okay, so output means pulsating DC, so that means pulse means there is a certain amount of AC. That is the two resistors are taken. IRM square, just now I got IRM square as what it is, this much. IRM is Im by 2. If you substitute here, Im square by 4. Now substitute these two values, AC value and DC value in this equation. Then what you get? You get here, see, it becomes like this, right? So when you substitute a DC power by AC power, so DC power expression is AC power expression is this one, and from this im square generally gets cancelled. So before that, take outside RL. If you take RL like this, then RL cancel, im square cancel, and this 4 goes upside and pi square is there. So that means 4 by pi square remains there. Okay, 4 by a square, and this is, and next to 4 by pi square value is 0.406, right? It is, and in terms of percentage is how much? 40.6. so that means how much capacity it has device? Just to 40% it can convert AC into DC. Which one? Half wave rectifier, only 40%. Next, ripple factors. What is ripple factor? A ripple means how much AC is there at output. Okay, how much is that is defined as the ratio of ripple voltage, means AC voltage to DC voltage, and it is denoted by gamma. Gamma is equals to ripple voltage or RMS component by DC voltage. Okay, and from this equation we can get this expression. So this expression is IRMS by IDC whole square minus 1. So we know IRMS value. IRMS is Im by 2. IDC is Im by pi. Okay, and both Im gets cancelled here. Im gets cancelled, and it becomes 1 by Im by pi, Im by 2. Im by pi becomes after cancelling Im, it becomes pi by 2. So if you simplify, if you square it and if you simplify, then you can get our gamma value as 1.21. So this is the pulsating. So that means the gamma value is more than 1, means AC value is higher is there at output in half wave rectifiers. Okay, so okay friends, this is a half wave rectifier. Don't forget it watching this video till the end. Okay, thank you.